Hello there. So for today we will look into chapter 9, okay, which will be on quantization of light. Okay, so for the first example, okay, we have example 9.1 over here. Okay, so for example 9.1, okay, you have a photon, okay, given with a green light, okay, which is a wavelength of 740 nanometer. Okay, so the wavelength over here given 740. So they wanted to calculate the photons frequency and then B, photons energy in joule and electron volt. Okay, alright, now for calculation purpose, okay, so the wavelength given, okay, we will apply equation C equivalent to F lambda. So basically this one we apply from the equation V is equal to F lambda lah. Okay, velocity of light. So over here, since we are using velocity of light, okay, which is constant, so V we replace with C lah. Okay, so lambda already given. So since C is constant, we can determine the frequency lah. Okay, so apply in, so determine the value of F, which will end up with 4.05. Okay, times 10 to the power of 14 hertz lah. Okay, then once you have the value of frequency, we can determine the energy ready. Okay, so where we apply E is equivalent to HF. Okay, H will be Planck constant. Okay, frequency was already determined in question A, so apply in. Okay, so we will end up with 2.69 times 10 to the power of negative 19 joule. Okay, so the answer they wanted to calculate in joule and electron volt. Okay, so for electron volt, use the conversion. Okay, so 2.69, okay, divide by EV, okay, 1 electron volt. Okay, so which will end up the final answer with 1.66 EV. Okay, so this is for question number example 9.1. Okay, so for example 9.2, okay, we have a gamma radiation, okay, and then the value of the wavelength given over here, okay, propagates in air. Calculate the energy of a photon for gamma radiation in electron volt. Okay, so for calculation, we can do it like example 9.1 lah. Okay, so basically, so over here what they do is that they simplify the equation lah. Okay, so since E is equivalent to, okay, HF, okay, frequency, and then we also know C is equivalent to F lambda. So rearrange in terms of F. Okay, so therefore F will be equivalent to C over lambda. So just replace this one over here lah. So that is why you end up with E is equivalent to HC over lambda. Okay, for this equation. So since you have rearranged, so straight away you can replace in. Okay, so you will end up with the final answer, which is given in joule. Okay, so to convert into EV, okay, divide with constant value of E, so which will end up with 2.69 times 10 to the power of 5 electron volt. Okay, okay, alright, so for example 9.3, okay, example 9.3 involves a work function lah. So this one, you have a material which has a work function of 4.22 EV. Okay, so they wanted to calculate the threshold frequency. So basically the threshold frequency will straight away depend on the work function over here. Okay, and then B, maximum speed of the photoelectron, okay, when the cadmium is shined by a UV radiation, okay, wavelength given over here lah. Okay, and then see the stopping potential. Okay, so all the value of constant given over here, okay, velocity of light, okay, value of H, okay, mass of electron, and the charge of electron. Okay, alright, now for solution. Okay, so work function, first step we convert into joule. Okay, we convert into joule. Since it is given in EV, convert to joule. Okay, and then by using the work function, we can determine the threshold frequency. Okay, constant times with threshold frequency, so which will end up with 1.02 times 10 to the power of 15 hertz lah. Okay, so done with A, we can move on to B. Okay, now for question B, the wavelength is given. Okay, so by applying Einstein equation, so maximum kinetic energy, okay, will be equivalent to the energy minus with the work function. Okay, so rearrange. Okay, so energy will be equivalent to, since we have lambda, so rearrange in terms of lambda lah, Hc over lambda. Okay, so replace in, okay, mass of electron already given, constant. So now we are going to find the value of V, which will be the maximum velocity. Okay, so solve it lah. So that means kinetic energy will be equivalent to total energy minus with work function. Okay, so whatever energy that you provide, okay, so KE max will be equivalent to E max minus with work function. Okay, so whatever energy that they provide more than the work function will be converted into kinetic energy. Okay, okay, so the stopping potential. Okay, so basically the stopping potential will be equivalent to the amount of maximum kinetic energy. Okay, so once have excess kinetic energy, okay, so the electron will move even without you providing potential. Okay, so what you do is that you provide a potential to stop the moving electron. So the potential that you provide will be equivalent to the maximum kinetic energy lah. Okay, so since we already have the value of velocity, okay, we can determine the equation. Okay, to determine the value. So once you have the value, we can provide, we can find the value of stopping potential over here. Okay, which will be equivalent to EV lah. Okay, so final answer which you end up with 0.303. Okay, so for example 9.4, okay, this one you have a beam of white light. Okay, so white light, that means you have a mixed spectrum lah. Okay, so containing frequency between 4 times 10 to the power of 14 hertz up to 7.9, okay, times 10 to the power of 14 hertz. Okay, incident on a sodium surface. Okay, and then the work function over here is given. Okay, work function given as 2.28 EV. Okay, so they wanted to calculate the threshold frequency of the sodium surface. Okay, so threshold frequency, we can refer back to the work function over here. Okay, and then the range of frequency in this beam for which electron are ejected. Okay, so electron ejected will depend on the work function lah. Okay, whenever you shine light, okay, if the frequency overcomes the work function, then you will have electron being ejected. So this one will depend on the answer on A lah. Okay, and then highest maximum kinetic energy. Okay, maximum kinetic energy lah. Okay, alright, now for the first solution A. Okay, so to determine the threshold frequency, work function already given, convert into joule. Okay, so using the equation, work function equivalent to H times F naught. Okay, so recalculate, so you will end up with the threshold frequency. Okay, which is equivalent to 5.51. Okay, now for the range, okay, frequency that eject electron. Okay, even though we shine with the lower frequency, it will start to emit electron once it reaches the threshold. Okay, so that means that it will have enough energy to emit electron. So that means this will be the minimum value lah. Okay, so this will be the minimum value and this will be the maximum value lah over here. Okay, so because the light has a certain amount of spectrum, so this will be the maximum value. Okay, so for the highest, okay, highest kinetic energy will depend on the highest frequency. So since we have the maximum frequency, this is, okay, so we will determine the highest kinetic energy based on the maximum frequency lah. Okay, so to determine the highest kinetic energy, okay, total energy minus with the work function lah. Okay, so okay, maximum, okay, total energy, okay, which you provide, which will depend on this frequency, minus with the work function. Okay, okay, so for example 9.5, okay, so this one explanation lah. Okay, so why does the existence of a threshold frequency in the photoelectric effect favor a particle theory for light over a wave theory? Okay, provide one suitable explanation. Okay, in photoelectric effect, explain why the stopping potential depends on the frequency but not on intensity. Okay, so we can refer back to the experiment. Okay, so wave theory predicts that the photoelectric effect should occur at any frequency, okay, provided the light intensity is high enough. But when we conduct the experiment, okay, the light must have a sufficient frequency, okay, greater than threshold for the effect to occur lah. Okay, so this one shows that, okay, supporting lah, okay, supporting the particle photoelectric effect lah. Okay, okay, B for stopping voltage. Okay, measure the kinetic energy most of the energetic photoelectron. Okay, each of them has gotten its energy from a single photon. According to quantum theory, okay, the photon energy depends on frequency of the light lah. Okay, the intensity controls the number of photon, okay, which is supplied. But according to classical says you should be able to have emission if you have enough intensity. Okay, but the experiment shows the other way around lah. Okay, okay, for the last example, example 9.6, okay, this one in a photoelectric experiment, a graph of the light frequency f is plotted against maximum kinetic energy lah. So that means we have a graph f versus ke lah. Okay, okay, shown over here. So based on the graph, okay, for the light frequency, okay, so this one is the incident light frequency lah. Okay, light frequency. They wanted to calculate the threshold wavelength and then the maximum speed of the photo electron. Okay, so now over here we have this intercept over here. Okay, so this value is given. Okay, so based on this, okay, what we can do is that we can analyze the graph lah. Okay, now for the solution. Okay, so if we rearrange lah, okay, HF, Kmax plus work function, right? Okay, so now we are plotting frequency versus K, F versus K. Okay, so rearrange in terms of F and versus K. Okay, so work function over Planck constant, you will end up with F naught. Okay, which will be the threshold frequency. Okay, so if we compare with the graph, okay, F versus K, okay, so this will be Y versus X, okay, gradient, and plus C. So C will be the intercept over here. Okay, 4.83. So this will be the intercept lah. Okay, so which will be the threshold frequency. Okay, okay, so once we have the threshold frequency, okay, we can determine the threshold wavelength by using the equation C equal to F lambda. Okay, so C will be constant, so where you end up with threshold wavelength 6.21 lah. Okay, so this one we obtain by analyzing the graph. Okay, now for solution B. Okay, so now we are going to determine the maximum kinetic energy, right? Okay, so rearrange. Okay, so that means you will end up with HF minus HF naught. Okay, so F and F naught. Okay, so F naught is already given in the graph, F is stated in the question. So just arrange over here lah. So arrange over here. So solve the equation to find the final value. Okay, so which will be the maximum velocity. Okay, so that's all for chapter 9. Okay, so have a nice day. So see you all again at chapter 10.